Hello and welcome back to another VMK in the game development series. In this video I'll be showing you how to add a texture transform to your textures. Now usually when you do this, it's an easy way to allow you to give animation into simple geometries in your scene. So for instance, if you have a box and you want the box to look like it's moving or something, you could go ahead and move the box. However, if you want to give some special effects, you can also move the texture that's on the box to make it look like the box is sort of wiggling or moving or rotating or whatever. You can actually do quite a few things with these texture transforms. So I'm going to show you how to implement that in this video. To begin though, let's go into our code, and you'll notice that if you tried compiling right at the very end of the last video, you would have gotten this error, undeclared identifier. And that's because we went into the material.h file and we deleted this variable m_bVisible. However, in the material.cpp, in the constructor that is, we never deleted this one initialization. So you need to go and delete that as well. And as I said before, in a future video, and I think it's going to be the next video, I'll show you how to re-implement this visibility so that you can make objects disappear out of your scene when you need to. So if you go and build it now, everything should be okay. Okay, and it is. Now to start by adding this texture transform class, what we're going to need to do is go into the Solution Explorer, and inside the scene lid we're going to go and right click, select Add New Item, and in here we're going to add texture transform, and that's going to be a .h file, and we're going to repeat that for the CPP. Okay, in the .h file, this is what you should see. At the top we have our standard if not defined define, and then we have our class. And our class itself is very simple. It just has a constructor and a destructor and 4 member variables. It has a scale, which is 2 parameters, an x and a y. We have a rotate, which is how much we're going to be rotating along one axis, and I'll show you which axis in a minute. We have a center, which is also x and y, and a translate, which is also x and y. And that's basically it. And as you can imagine, inside the texture transform.cpp, we're going to have something very simple in here. Inside of our constructor, we just initialize all of the parameters that are members of us to certain values which we find are acceptable. And these values should be the standard values to make our texture look as if it always does up till now. So the scale for all our texture should be 1, 1, meaning we're not stretching or shrinking our texture. We're not going to be rotating the texture initially, so it's going to be oriented exactly the way we expect it to be. The center of the texture is going to be located at 0, 0, and we're not going to translate the texture either. So the center and the translate, you'll see how these two play a role in a minute. And our destructor doesn't need to do anything, so I just left it blank. Okay, let's just go and compile this, make sure everything's okay, and indeed it is. So we can now go inside of our scene class and implement how we go about to use this new texture transform. Let me close these materials off. Let's go into the .h file. To start working with these texture transforms, we need to implement a couple functions that will be able to allow us to work with them. And I'm going to put these functions right here underneath where we're doing all the texture stuff. So the 3 functions we're going to need is delete all texture transforms, save texture transform, and assign texture transform. And you'll notice that these are very similar to what we did here with the material. We have save material, delete all materials, and assign material. Same thing, delete all texture transforms, save, and assign. So inside of our clear all, we need to make sure we go and call delete all texture transforms. Oh, I guess that was a bug that I missed previously. If we are using textures, make sure that you uncomment this line of code here so that we go and delete all the textures that we're going to be using. So we also need to add into here now, delete all texture transforms. Okay, and we commented out delete all fonts. Are we using fonts in our engine right now? Oh, it doesn't hurt to remove that comment, since if there are no fonts in the scene, it shouldn't crash and the program should continue running. As a matter of fact, we can go and delete these old ways of handling the window in the house, since we're no longer going to be writing our code that way, so we don't need those. Spelling mistake there. Okay, so there's delete all texture transforms, delete all fonts, and let's go back into here now. So that takes care of this guy. Now we need to be able to save texture transforms, and we also need to be able to assign them to specific shapes. Well, let's go see how we can use this. Inside of our scene initialize, what we're going to do is we're going to create a scene that has just a simple plane that I'm going to put a texture on. And then we're going to play around with this texture by manipulating the texture transform parameters. And this will hopefully show you how each of the different texture transforms work with specific textures. Oh, there is one thing I forgot to do. Back in here, the saving texture transforms and assigning texture transforms, they're going to work with a container. And just like the container used to hold all the textures, we need to create a new container to hold all the texture transforms as well. So that's what I've done here. STD vector, it's going to hold texture transform pointers, and I'm just calling it m_vp texture transforms. Okay, now we're ready to go inside the scene initialize. And let's see what we have here. We have a point light source, and then in our scene we've created one texture here, and we have a material, and then we have a geometry for the box. We won't be using that for this demonstration, but I'm just going to leave it in the scene here. It doesn't hurt to have it in here. And we have a flat grid, which is used for the ground. Well, what I'm going to do is create another flat grid, and this is the item that we're going to use to represent the plane that will have the texture that we're going to be manipulating. So I'll call this p-plane, and we're going to make it of size 1 by 1, and it's going to only have one division in the U direction and one division in the V direction, or I guess in these coordinate systems it would be in the X and in the Z direction. Okay, and then we want to go and save this geometry. Okay, then down here we have the root transform, which moves us back 2 units. We create the ground and we place it down, and then here we created a transform to nest our boxes. Okay, so we're going to change this guy. So let's delete these 2 lines of code and replace them with the following. I know I'm going to be placing my plane underneath this node, so what I want to do is rotate the plane by 90 degrees about the x-axis. So I've set the rotation axis to x and the rotation angle by 90 degrees, and then I'm going to translate the plane up half a unit, since the plane itself is 1 by 1, but this is the center of the plane. So I want the full plane to be above the ground, so I need to move it up by half a unit, and then I just go and add that add this transform to the previous transform here, which was the root one. Okay, and then we have our shape. Now our shape, we want to be the plane, and down here we're going to add this shape to this guy, so that's fine, and we're going to assign a texture, which is the one we loaded before, and we're going to assign a material. Okay, that should be fine, and then I'm just going to delete this other stuff since we're not going to need it. Let's go and build this and make sure that we have a plane on the screen. Okay, we're getting some error messages here saying that texture transform is unidentified, and that's easily fixed just by going to the top here and including the texture transform .h, which we just created. And we have a warning here. We can just comment this line out. We're not using that just yet. What's this? Delete all texture transforms, unresolved external symbol. Oh, we're having problems compiling because we haven't defined delete all texture transforms. We haven't written the code for this function yet, nor have we written these two functions either. So the compiler is going to complain saying that we're trying to use this, but there is no code for it. So we have to go and implement this. I'm going to implement this delete all texture transforms right underneath delete all textures. And here it is here. So first thing we do is create this std vector iterator, which is going to point to the beginning of the texture transform container. It's going to iterate all the way to the end of it, going one by one through the iterator. Each time, it's going to go and delete the pointer that's inside the container, and then once it goes through all of those, it's just going to clear out everything that's inside the container itself. And that's it for the delete all texture transform. We should now be able to build this and run it. And there we go. We see the one plane in front of our eyes, and the object is textured because we've assigned a texture to it. One thing that I should mention is inside the initialize, if you want to be able to see through that window inside the texture, make sure you go into here and underneath the texture constructor, you set this last parameter to false. If it's true or not present, then that means that we're rendering the object to be solid, and therefore you won't be able to see through that white space at the very top. If we set it to false, then we'll be able to see through it as if it's just like a window. Okay, now let's go and see how we can implement the texture transform stuff into our shape node. Our shape node contains all of the data for the geometry that we're rendering. And you remember at the top here we've commented out this texture transform part. Well, now that we've implemented this, we can uncomment this line of code, and we can also uncomment this line of code so that we have a pointer to a texture transform. Inside the node shape.cpp, we need to also implement a couple things. Inside the constructor, we set that member variable to be null, because initially it's not assigned to anything. And then inside the render OpenGL, we need to handle some special cases in case this does get assigned to us. Okay, the texture transform doesn't play any role if there's no textures. So if we go down in here, if we have a texture, we're going to be using texture transform. However, if we're in here, there's no need to do anything with the texture transform since we know we're not using a texture. So the only place we're going to have to implement some change is inside this if statement here, where we're checking to see if we have a texture. And the texture transform has to get adjusted before we render the geometry. So we need to make a couple changes here above this render call. However, after we do the render call, we want to undo everything that we did here above so that all the texture transforms don't affect any other objects inside of our scene. And here's how we're going to do it. I'm just going to take these two lines of code and replace them with the following. We have a check to see if we have a texture transform. And remember, initially in the constructor we set it to null, so if we don't have it, we just skip over this part. However, if we get it assigned to us, then we'll go into here. And what we do is we take the texture transform matrix and we push it onto a stack. Very similar to what we did inside the node transform with the GL model view matrix. Here, now we're working with the texture matrix. We then reset the texture transform matrix to be identity, so that means everything's cleared. And then we apply all the different parameters that we have stored inside the texture transform. So first thing we do is we translate the textures by whatever value we have stored in the X as well as in the Y. We then go in, move the center by X and Y, and you'll notice here that the Z parameter is set to 0 because the texture transform is a two-dimensional planar kind of activity. So there is no Z component that we worry about. We can only translate in the X or Y direction. We can't translate in the Z. And that sort of makes sense because imagine having a flat plane. If we put a texture on that flat plane, we can't change the depth of where that texture is, or else we wouldn't see it on the geometry. So it's always fixed to 0. Same thing with the center. The center is the location of where we're going to be rotating about. And this is defined by the center parameter, which we're assigning to GL translate F here again. If we need to rotate the texture, we then go and call GL rotate F with the rotation value here in degrees, and we're rotating about the Z axis. So here we define 0, 0, and then 1 because that's the Z axis. Then we do a scaling in case we need to scale the texture, and by default the scaling value we've set to be 1, 1, so we're not shrinking or enlarging the texture itself. It's always just the same size. And here you must remember the Z component, leave it at 1 since that's the default. And then lastly, we need to correct by the center by moving it in the opposite direction that we did here initially. And that's why we're taking the minus of the center value for the X and then the minus of the center value for the Y. And that's it. So then we go and render, the same as we did before. However, when we're done, we need to go and do the following. And here, if we did do something up here, we need to undo all of this. And the way we undo it is we just take the GL matrix mode for the texture and we pop it off the matrix stack. So here at the very beginning, we push it onto the stack, so we save it, we change it, we render, and then we go and reset it back to whatever it was before we came in here. So that's how we handle the texture transform stuff. Now, we can go actually compile this, make sure everything is fine, and it is. Good. Now we can go back into the scene.cpp file and implement a texture transform for our specific geometry. So let's see. Let's put it right underneath this texture here. Okay. The way we create a texture transform is we create a local texture transform pointer. We'll call it pTextTransform. We call the new operator just to call the texture transform class. If this creates correctly, then we continue on down. Otherwise, we generate an error message. And then if it is okay, we go and save that texture transform into our container that holds all the texture transforms. We haven't written this function yet, so don't worry about that. And this function is going to return to us a ID number, which we'll then use to assign this specific texture transform to a specific shape node. So we're going to go down to our shape node now for our plane. And down here, we can then go and call assign texture transform. And we need to pass into it a shape ID and a texture transform ID. Oh, I just noticed here we're not supposed to call this function inside the geometry. We're supposed to call it inside of the node shape for our plane. So we have to do it down here. Okay, so we're going to be assigning a texture transform to a specific shape. The shape we want to assign it to is this one here. So we're going to use UI node ID2, and the texture transform we're assigning is the one we saved up above. And where was that? Right here. Here it is here. Okay, so that's the way that our new functions are going to work. Very similar to how we're handling everything else. Now we can go and write the code for this assign texture transform as well as for the saving of the texture transform inside of the container. We'll start with the assigning of the texture transform. And I'll put that right underneath assign texture. So here we have the following code. Again, we're assigning this specific texture transform ID to a specific shape ID. So we need to first check to make sure that these ID numbers are valid. And we do that by checking to see if the texture transform ID number is greater than the container size that holds all the texture transforms. If it is greater, then it's invalid, so we return an error message. Otherwise, we'll continue on down through. We then check to see if the shape ID number here is valid by comparing it with the node size. If it is valid, we continue on through. And then we check to make sure that the specific shape ID that was passed in is actually a shape. We can't assign a texture transform to anything other than a shape node, so we need to make sure that it is a shape node. And then if everything passes, then we can take our node, which is stored inside of a container. We dereference this ID number so that we can get it out of this container. We cast it to be a node pointer or a node shape pointer, and then we assign the pointer for the texture transform for this guy equal to the texture transform that was stored inside of this container, referenced by the ID number that was passed in here. So again, you've seen this already with the textures and the materials and everything else. Nothing new here. And finally, we just have to add the other function. And this function will save the texture transform inside of this this container here so that we can call it whenever we need to. And I'm going to put that right underneath delete all texture transforms. So save texture transform, we're passing in a pointer to a texture transform. First thing we do is we check to see if that pointer is valid. If it's invalid, we return an error. Otherwise, we just push back the texture pointer onto the container that we're going to use to store everything. And then we return the ID number for this specific texture. Again, same as everything else we've done before. Alright, now if we go and build this, it should build and run. However, you shouldn't see any difference from before. And the reason for that is we haven't done anything to the texture transform yet to show you any differences. So not very exciting yet. Well, now let's go into our, well, go back into initialize for a second. Just need to refresh my memory here. For the texture transform, we need to, actually, not the texture transform, I'm looking for the node shape that the texture transform is attached to, which is down here. Okay, so we are assigning to this shape the texture transform we loaded up above. Well, I want to be able to easily access this node shape, so what I'm going to do is I'm going to take the shape node and assign a name to it. And the name I've chosen here is moving, because we're going to go and move the texture transform inside it. So now that it's named, inside of our update, where's our update? Here, we can go look for that node and then make some changes to it dynamically to show you how the texture transforms work. So we create a node pointer, and we're going to look for the node named moving. If we find it, what we want to do is the following. If pNode exists and pNode is a shape, remember it has to be a shape because that's what we defined above, but it's good practice to double check to make sure it is a shape, then we can take our pNode, cast it to a node shape pointer, and then dereference our value for our texture transform. Using this, we now have access to our texture transform, so we can go and manipulate any of the parameters of the texture transform. And here what I've done is I'm taking the X component for the translate and I'm changing it by 0.001 units every time that this function is going to run. So in other words, every frame that our program is going to run, it's going to translate the texture by 0.001 0.001 units to the right. Well, let's go and run this and see what it does. There you go. And as you can see, the texture is actually translating along on the surface of our geometry. So we've basically dynamically created sort of a moving plane. Our plane itself, or our geometry, is not moving, it's just our texture is moving. And that gives you the feeling that the object is moving. So you can imagine using something like this for conveyor belts in a computer game. You would have a simple geometry for a conveyor belt shape, but rather than having to move the geometry for the conveyor belt, you can just move the texture that's mapped on top of that geometry, and it'll look like the conveyor belt is actually rolling. You could do it for a couple other things, or actually many other things, so be creative. That's how you can use the translation. You can go and manipulate in both the X as well as the Y direction. So if you wanted to do the Y as well, or let me just change this so we're just doing the Y direction, then we just reference the Y component, and again, every time through this update function, it's going to manipulate the texture. So now it's scrolling for us in the other direction. Okay, so that's how you handle translations. Now let me show you rotations. Let's say instead of wanting to translate, you wanted to rotate the object. Well, now I'm taking the rotate parameter inside the texture transform, and I'm going to change it by 0.1 degrees every time through this loop. I'm just picking these numbers arbitrarily just to show you what happens when we play around with the texture transform. In a real game, you'd want to control those parameters a little bit better. So there you go. You can see that the texture is actually rotating about the bottom left-hand corner. And everything kind of maps correctly. You'll notice that sometimes you'll see two windows on the geometry itself. And that's because when we created the texture, we set it up to wrap both in the U direction and in the V direction, or in the X and in the Y direction. So it's a continuous texture. Whenever the texture ends, it just starts over again a second time, and that's why sometimes when you rotate that object, you see two windows. So there you go. That's rotation. But let's say you didn't want to rotate about the bottom left-hand corner. Maybe you wanted to rotate about the top right-hand corner, or maybe even the center of the texture itself. Well, how would you do that? That's where you have to play around with the center point of a texture transform. Now, I could go and set the center point of the texture transform here inside the update. However, if I know that the center point is not going to change as I'm playing around in my game, it's always going to be fixed to a specific value, it's best to go and set the center value inside the initialize whenever we create the texture transform here. So that's what I'm going to do. Here I'm taking the texture transform, center value for the X coordinate and for the Y coordinate, I'm setting it to 0.5 and 0.5. This is going to set to the rotation point to the very center of the image. And let's go and take a look at that now. So now notice that the texture transform is making the texture rotate about the center rather than about the bottom left-hand corner. And I guess I can go into PaintShop Pro here and show you how these coordinates are working. You'll remember that with textures, let me try to draw here a rough drawing of what we have. With any textures inside OpenGL, bottom left-hand corner is 0, 0, and top right-hand corner is 1, 1. So what I've done initially is set the center point to be 0, 0. So as it's rotating about that point. However, if I move the center, like I did, to 0.5, 0.5, then that's halfway down this texture. So I've moved the center point to here, and now as I'm rotating, then it's rotating about this new location. And that's the way that everything is working. With the translations, it's also with respect to these coordinates, 0, 0, and 1, 1. So if I take a texture and I translate it by 0.5 units, then that means that whatever was drawn over here will be drawn right here because it's been translated by that much. So remember, if you translate by large numbers, you may not really notice a difference because you're skipping over the entire geometry. It's best to use numbers between 0 and 1 when you're iterating through so that you see a transition from like one spot to another spot and so on. And that's why you'll notice back here in the code, whenever I did the update, I'm using very small numbers so that there's a smooth transition or a smooth rotation, whatever, of the textures. The texture transform has a few parameters, as you'll remember from the beginning here. We have the scale, the rotation, the center, and the translation. So we already discussed the translation, the center, and the rotation. The last one is the scale. Well, you can scale a texture on top of the geometry by using this factor here. And what I'm going to show you now is a little bit fancy, but not too difficult. What I'm going to do is create two values here, a value of 0.5 and another value here of 1. Then what I'm going to do is assign the scaling in the x and the scaling in the y to whatever value this f value is set to. So initially, because this is a static member, it's going to be set to 5. But then every time else through, it's going to be whatever the math down here makes it to be. So what I'm doing is I'm taking the value and I'm adjusting it by 0.005 times this FPOS. So it's going to be incrementing by 0.005 every time. However, when the value reaches greater than 2, then I'm going to change FPOS to be negative, so it's actually going to be decreasing. So as a result, what I'm doing is I'm scaling the texture to be larger, larger, larger till it's 2 times its original size. Then I'm going to reverse it and start scaling it downward, downward, downward until it's half the original size, and then I'm going to reverse again. So it's just going to keep getting bigger, smaller, and so on. Don't worry if you don't really understand this code that much. It's just a quick demonstration to show you how scaling works. And there we go. So you see the texture itself is shrinking and growing on top of that geometry. The geometry itself is the exact same size. It's only the texture that's being scaled. So there you go. I hope this gives you some ideas of what you can do with texture transforms and what kinds of different animation effects you can get in your games. You can do quite a bit with texture transforms, a lot of neat tricks that simplify the amount of computations that the computer has to do to give you animation. Instead of having to move objects and move geometries, which can be computationally expensive, it's easier sometimes to move the textures that are on top of those geometries. Okay, come back for the next video where I'll be showing you how to make objects visible and make them invisible.